Today we're diving into the world of missing data, a common challenge in data analysis. Missing data can occur for many reasons, such as errors during data collection, system glitches, or even participants skipping questions in a survey. No matter the cause, missing data can impact the accuracy and reliability of your results. In this video, we'll explore why missing data matters, the problems it can cause, and most importantly, practical strategies to handle it effectively. Let's start by understanding what missing data actually is and why it's so important to address it before moving forward with any analysis. Missing data refers to the absence of values in a dataset where information should exist. This can happen in any field: healthcare, finance, marketing, and more. Sometimes missing data is obvious, like blank cells in a spreadsheet. Other times it's hidden, such as coded values that represent missing responses. Recognizing missing data is the first step in handling it. If left unchecked, it can skew your analysis, leading to misleading conclusions. That's why it's crucial to identify and understand the patterns of missingness before deciding how to address them. Not all missing data is the same. There are three main types: missing completely at random (MCAR), missing at random (MAR), and missing not at random (MNAR). MCAR means the missingness is unrelated to any data observed or unobserved. MAR means the missingness is related to observed data but not the missing data itself. MNAR means the missingness is related to the value of the missing data. Understanding these types helps you choose the right strategy for handling missing data and ensures your analysis remains robust and reliable. You might wonder, why is missing data such a big deal? Well, missing data can reduce the statistical power of your analysis, introduce bias, and even lead to invalid results. For example, if survey responses are missing from a particular group, your findings might not represent the whole population. Ignoring missing data can also affect machine learning models, making predictions less accurate. That's why it's essential to address missing data thoughtfully, using methods that suit your dataset and research goals. Before you can handle missing data, you need to detect it. This might sound simple, but missing data isn't always obvious. You can use summary statistics, visualizations, or specialized functions in data analysis tools to spot missing values. For example, in Python's pandas library, the isNull function quickly highlights missing entries. Visual tools like heat maps can also reveal patterns of missingness across your dataset. Detecting missing data early helps you plan the best approach for dealing with it. Once you've detected missing data, it's important to quantify it. This means calculating how much data is missing and where it occurs. You can compute the percentage of missing values for each column or row. High percentages might signal a bigger problem, while small gaps could be easier to handle. Quantifying missing data helps you decide whether to remove, impute, or otherwise address the gaps. It also provides transparency when reporting your analysis. Visualization is a powerful way to understand missing data. Tools like heat maps, bar charts, or matrix plots can show you where missing values cluster in your dataset. These visuals make it easier to spot patterns, such as missing data concentrated in certain variables or time periods. By visualizing missingness, you gain insights that might not be obvious from raw numbers alone, helping you choose the most effective handling method. Missing data can arise from many sources. Sometimes it's due to human error, like skipping survey questions or entering data incorrectly. Other times, technical issues such as system crashes or data transfer problems are to blame. In some cases, missing data is intentional, such as when sensitive information is withheld. Understanding the root cause helps you determine whether the missingness is random or systematic, which is key for choosing the right handling technique. Missing data doesn't just create empty spaces, it can distort your entire analysis. For example, if key variables are missing, your statistical tests may lose power and your models may become less accurate. In some cases, missing data can even change the direction of your findings. That's why it's crucial to address missing data before drawing any conclusions from your dataset. One approach is to simply ignore missing data, but this is rarely recommended. Ignoring gaps can lead to biased results, especially if the missingness is not random. It's important to assess the extent and pattern of missing data before deciding to proceed without addressing it. In most cases, you'll want to use more sophisticated methods to ensure your analysis remains valid. Listwise deletion, also known as complete case analysis, involves removing any row with missing data from your dataset. This method is simple and easy to implement, but it can significantly reduce your sample size. If the missing data is not random, listwise deletion can also introduce bias. It's best used when missingness is minimal and random, ensuring your results remain representative. Pairwise deletion is another approach where only the missing values are excluded from specific analyses, rather than removing entire rows. This method preserves more data but can lead to inconsistent sample sizes across different analyses. It's useful when missing data is scattered and not concentrated in specific variables. However, it's important to be cautious, as results from pairwise deletion can be harder to interpret. Mean imputation is a common technique where missing values are replaced with the mean of the observed values for that variable. This method is easy to apply and keeps your dataset complete. However, it can underestimate variability and distort relationships between variables. Mean imputation works best when the amount of missing data is small and the data is missing at random. For variables that are skewed or categorical, median or mode imputation can be more appropriate than mean imputation. Median imputation uses the middle value, while mode imputation uses the most frequent value. These methods help preserve the distribution of your data, but like mean imputation, they can still reduce variability and may not be suitable for all situations. Regression imputation predicts missing values based on other variables in your dataset. By building a regression model, you can estimate what the missing value is likely to be. This method can be more accurate than simple imputation, but it assumes that the relationships between variables are strong and consistent. Regression imputation is best used when you have enough data to build reliable models. ANN imputation fills in missing values by looking at the nearest neighbors, rows in your dataset that are most similar to the one with missing data. The missing value is then estimated based on the values of these neighbors. KNN can capture complex patterns, but it can be computationally intensive, especially with large datasets. It's a flexible method that works well when data is missing at random. Multiple imputation is a sophisticated technique that creates several different imputed datasets, analyzes each one, and then combines the results. This approach accounts for the uncertainty of missing data and provides more accurate estimates. Multiple imputation is widely used in research and is considered one of the best practices for handling missing data, especially when the missingness is not completely random. Machine learning algorithms can handle missing data without any imputation. For example, decision trees and random forests can split on available data, making them robust to missing values. Using such algorithms can save time and reduce the risk of introducing bias through imputation. However, it's still important to understand the nature and extent of missing data in your dataset. Data augmentation involves creating new data points from existing data to fill in gaps. This can be done using techniques like bootstrapping or synthetic data generation. While data augmentation is more common in fields like image analysis, it can also be applied to tabular data to address missingness. It's important to use these methods carefully to avoid introducing artificial patterns. Sometimes the best way to handle missing data is to use your domain knowledge. For example, if you know that a missing value should logically be 0 or a specific category, you can fill it in accordingly. Domain expertise can help you make informed decisions and avoid common pitfalls in imputation. Always document your choices and the reasoning behind them. When you fill in missing data, it's a good practice to flag those values. This means creating an indicator variable that marks which entries were imputed. Flagging helps you track changes and assess the impact of imputation on your analysis. It also provides transparency for others who may use your dataset in the future. Transparency is key when handling missing data. Always report the amount and pattern of missingness in your dataset, as well as the methods you use to address it. Clear reporting helps others understand the limitations of your analysis and builds trust in your results. Include details in your documentation or research papers for full transparency. After handling missing data, it's important to check how your results might change under different assumptions. Sensitivity analysis involves repeating your analysis using different imputation methods or assumptions about missingness. This helps you assess the robustness of your findings and ensures that your conclusions are not overly dependent on a single approach. Handling missing data is both an art and a science. Best practices include understanding the pattern and cause of missingness, choosing appropriate methods, and documenting your process. Always consider the impact of your choices on the validity and reliability of your results. By following best practices, you can minimize bias and make the most of your data. Many data analysis tools offer automated solutions for handling missing data. For example, Python's Pandas and scikit-learn libraries provide functions for imputation, while R has packages like Mice and Amelia. These tools can save time and reduce errors, but it's important to understand how they work and to review their results carefully. Sometimes, standard imputation methods aren't enough. You might need to write custom functions to handle unique patterns of missingness in your data. Custom solutions can be tailored to your specific needs, but they require careful testing and validation. Always check that your custom imputation doesn't introduce new biases or errors. Imputing missing values in categorical data requires special care. Common methods include replacing missing values with the mode or using predictive models like decision trees. It's important to preserve the distribution of categories and avoid introducing artificial patterns. Always check the impact of your imputation on downstream analyses. Time series data often has unique patterns of missingness, such as gaps in measurements over time. Methods like forward fill, backward fill, or interpolation can help fill these gaps. It's important to choose a method that makes sense for your data and to check how imputation affects trends and seasonality. Survey data is especially prone to missing values as respondents may skip questions or drop out. Techniques like imputation, weighting, or using auxiliary variables can help address missingness. It's important to consider the reasons for missing data and to report how you handled it in your analysis. Large datasets can present special challenges for missing data. Imputation methods that work well on small datasets may be too slow or resource-intensive for big data. Scalable techniques, such as parallel processing or using specialized libraries, can help you handle missing data efficiently without sacrificing accuracy. Handling missing data isn't just a technical issue, it also has ethical implications. Imputation choices can affect the fairness and validity of your analysis, especially in sensitive areas like healthcare or social research. Always consider the ethical impact of your decisions and strive for transparency and fairness in your approach. In some fields, there are legal or regulatory requirements for handling missing data. For example, clinical trials often have strict rules about how missing data is reported and addressed. Make sure you understand any relevant guidelines or regulations in your field and document your compliance carefully. Handling missing data often requires collaboration between data scientists, domain experts, and stakeholders. By working together, you can combine technical skills with domain knowledge to choose the best strategies. Collaboration also helps ensure that everyone understands the limitations and strengths of your analysis. Missing data isn't a one-time problem. As you collect new data, continue to monitor for missingness and update your handling strategies as needed. Automated alerts or regular data quality checks can help you catch issues early and maintain high-quality datasets over time. Good documentation is essential for reproducibility. Always record the steps you took to handle missing data, including the methods used and any assumptions made. Clear documentation ensures that others can replicate your analysis and understand the impact of missing data on your results. Let's look at a real-world example. In healthcare, missing data is common due to patient dropouts or incomplete records. Researchers often use multiple imputation or domain knowledge to fill gaps. By carefully handling missing data, they can ensure that their findings are accurate and reliable, ultimately improving patient care. In marketing, missing data might occur when customers don't provide all their information. Marketers often use imputation or predictive models to fill in gaps, ensuring that their campaigns are targeted and effective. Handling missing data well can lead to better customer insights and improved business outcomes. Financial datasets can have missing values due to reporting delays or errors. Analysts use a combination of imputation, deletion, and domain knowledge to address these gaps. Proper handling of missing data is crucial for making sound financial decisions and maintaining regulatory compliance. Survey data is often incomplete, with respondents skipping questions or dropping out. Researchers use techniques like weighting, imputation, or auxiliary variables to address missingness. By carefully handling missing data, they can ensure that survey results are representative and trustworthy. In machine learning, missing data can affect model performance. Some algorithms can handle missing values directly, while others require imputation. Choosing the right approach depends on the algorithm and the nature of the missingness. Proper handling ensures that your models are accurate and robust. There are several common pitfalls when handling missing data. Overimputation can introduce artificial patterns, while ignoring missingness can lead to bias. Using inappropriate methods can distort your results. Always choose methods that fit your data and research goals and avoid shortcuts that compromise quality. The field of missing data handling is evolving rapidly. New methods such as deep learning-based imputation and advanced statistical techniques are emerging. As data grows in size and complexity, staying up to date with the latest trends and tools will help you handle missing data more effectively. Let's recap what we've covered. Missing data is a common challenge in data analysis, but with the right strategies you can handle it effectively. Key steps include detecting, quantifying, and visualizing missingness, choosing appropriate handling methods, and documenting your process. By following best practices, you can ensure your analysis remains accurate and trustworthy. Handling missing data is an essential skill for anyone working with data. By understanding the causes and patterns of missingness, using appropriate techniques, and maintaining transparency, you can turn a potential problem into an opportunity for better analysis. Keep learning, stay curious, and always strive for high-quality data. Thank you for joining this deep dive into handling missing data. Now that you're equipped with practical strategies and best practices, you're ready to tackle missing data in your own projects. Remember, the key is to approach missingness thoughtfully and systematically. Good luck on your data journey.